Let's see about clock latency, and here set clock latency is the SDC command. Coming to clock latency. Clock latency is a delay between the source of a clock and the actual pin where the clock is used to trigger a sequential device. So here sequential devices can be flip-flops or the latches. This delay arises due to capacitive loads on the interconnect and elements in the clock tree between clock source and the clock pin. So this is the figure. Let's see it. So you can see here. So this point you can consider as the place where the clock is generated by using the source. So you can take this as some PLL, that is phase lock loop. So from here to clock definition point, it is called as source latency, and from clock definition point to the pin of the sequential device is called as network latency. So you can see from this figure, from clock definition point to this is one of the clock pin, and from another clock definition point to one of the clock pin. So that's why you can say this is one network latency and this is another network latency. And here if you see this source latency, that is PLL, which is present outside of the chip. Here this bounding box is something you can take it as chip, and if it is present outside, it is called as off chip. Suppose if this source is also present within the chip, I mean within this bounded box, then you can call it as on chip clock. So this is off chip clock, this is on chip clock. Again the concept will be same, but here on the chip the source is also present. So from PLL to clock definition point, it is called as source latency, and from clock definition point to the clock pin of the sequential device, it is called as network latency. So be clear with this. And for source latency only, we will be making use of switches called as hyphen early and hyphen late. So I'll be showing you how to write the constraint for this, followed by the detailed switches that are used. You can see here the longest path is called as the late path, and the shortest path is called as early path. Remember these 2 points. Longest path will have more delay, so it is called as late path, whereas shortest path will have less amount of delay, so that's why it is called as early path. Coming to components of clock latency, and this is a figure which we have seen already. It has two things. One is source latency and network latency. Source latency is nothing but coming from the clock source to the clock definition point. Network latency means from clock definition point to the clock pin of the sequential device. It is called as network latency. So see each and everything in detail. Coming to source latency, delay from the clock source to the point where the clock is defined. So generally we are defining the clock by using create clock, or else if it is generated clock, you need to use this particular SDC called as create generated clock. I have made a detailed video on these two concepts. Please go through that. The clock source can be on chip or off chip. As I told you, suppose if the PLL is present outside the chip, then it is called as off chip. It is present within the chip, then it is called as on chip. Coming to network latency, delay from the point of clock definition point to the sequential elements where it is actually used is called as network latency. Multiple clock paths may exist to a device. That is longest path called as late path, which will be having maximum delay, whereas shortest path will have minimum delay, so it is called as early path. Coming to total clock latency, so total clock latency is calculated as summation of source latency followed by network latency. So simply if you summation the values of source as well as network, you will get the complete total latency. Accurate clock latency calculation requires complete implementation details like placement, wire connections, parasitics, buffer insertions, which are usually available post layout. So after post layout only we will be getting the exact values, whereas in pre-layout we will be assuming some values by using SDC constraints. Coming to pre-layout modeling, that is before clock tree is built, that is before CTC or in the pre-layout stage, designers approximate network delays using the SDC constraints called as set clock latency. Set clock latency allows STA tools to account for clock network delays prior to actual CTS and placements. So once after post layout, that is after clock tree is getting built, then we will get the accurate values. If not, before that we need to assume some values. Let's see about set clock latency. So set clock latency, this is the structure, I mean you can take it as syntax. So clock latency is modeled in SDC using set clock latency command. These are the switches, that is rise, fall, min, max, source, late, early. Clock is one more switch, and we have to give the delay value followed by the object list. So you can see here rise and fall, it is used to specify latency for the rising or falling edges of the clock, whereas min and max, it specifies latency under minimum and maximum operating conditions. Hyphen source, you have to use this particular switch if you want to mention source latency. If you don't want to mention source latency, simply don't use this switch. If you are not using hyphen source, then by default it will be treated as network latency. So hyphen source, it is used to model source latency. that is delay from clock source to the point where the clock is defined. Example, ports or PLL output. Coming to early and late, this early and late should be used along with hyphen source. So model the shortest or the longest path from the clock source. So you can see here, shortest path will have less delay, that is nothing but minimum delay, so that's why it is called as early, whereas long will have max delay, so that's why it is called as late path. Next, hyphen clock followed by the clock list. Associates the latency with a specific clock when multiple clock passes through a port or a pin. Care must be taken not to contradict latency values. So latency should not be negative. And one more thing, max latency cannot be less than min latency. There should be certain range between min and max. Coming to source latency, coming to definition, we already know this. Delay from clock source, that is on chip or off chip, to the point where the clock definition point is present is called as source latency. And this is the SDC constraint, set clock latency. So here we are using hyphen source. So this value is applicable for source latency. So set clock latency hyphen source this value, and we are applying to the get clocks C1. Next, coming to early and late parts. So if you want to mention this one, you have to use hyphen early or else hyphen late. And important point, this should be used only for source latency. Don't use this one, these two switches for network latency. So set clock latency hyphen source. So for source latency, early is 0.5, get clock C1, and set clock latency hyphen source late is 1.0, and this is for get clock C1. So impact on the static timing analysis. Setup check, it compares late source to early destination, whereas hold check will compare early source to late destination. So remember this point, if this is the actual clock and if it is moving towards right hand side, then it is called as late. If it is moving towards left hand side, it is called as early. So remember these 2 points so that you won't get confused between what is early and what is late. So late means it will have max delay, early means it will have min delay. That's why for setup it will have max delay, so that's why we are going for late source. For hold it will have min delay, so that's why we are going for early source. Next, coming to network latency. So delay through the clock network due to CTS, clock tree synthesis, buffers and fan outs from the point of clock definition to the sequential device. So simply from the clock definition point to the clock pin of the clock is called as network latency. And pre-layout modeling, it is approximate delays before CTS. Before CTS you have to give it by means of SDC. After CTS we have to give the actual values. So post layout you have to use set propagated clock. If it is pre-layout you have to go for this particular set clock latency SDC constraint. So simply remember 2 points, set clock latency use if it is pre-layout, whereas for post layout we get the accurate values, then go for set propagated clock. So use set propagated clock for accurate network delays, that is also called as insertion delay. And these are the examples. Set clock latency, this is a value for rise and applying for get clock C1, whereas set clock latency 0.3 for fall for get clock C1. So this is the example with respect to clocks. If it is with respect to the ports or pins, these are the examples. So network latency to all register clock pins in fan out of port A. So set clock latency, this is a value and we are applying for get ports A, whereas this one set clock latency, this is a value for clocks C1 and C2 and I'm applying to get port. So network latency to all register pins in fan out of B clocked by C1 and C2. So these are the SDC constraints how we write. Only 2 points you need to remember here. Simply use set clock latency if it is pre-layout. Use set propagated clock, it is post layout. So this is a summary difference between source and network latency. So source latency it applies to clocks only, whereas network latency is applicable for clocks, ports and pins, and it models delay from clock source, whereas this is for delay through clock network. And hyphen early and hyphen late should be used only for source latency, that's why it is yes, whereas for network latency it is no. Next, pre-layout usage, this is optional, whereas for pre-layout you have to use set clock latency. If it is post layout, then simply go for set propagated clock, whereas for source it is still relevant for clock propagation. And this is the figure I told you, if it is moving towards right hand side it is called as late, if it is left side it is called as early. So this is all about set clock latency. So I have made 2 videos on set clock latency. I will put it as part 1 and part 2. Please watch both the things, that is part 1 and part 2, so that it will be clear.